Okay, for tonight's notes, this is going to actually be the last section before your test next Friday. This is Chapter 6, Section 6. We're talking about graphing systems of inequalities. Okay, so when we had systems of equations, that was like two lines and we looked for the point where they met. Now we're going to have two inequalities and we're going to look for the area that they have in common. All right, so key thing we're focusing on is how do we solve these, or how do we come up with a region that represents the solution to a system of linear inequalities using graphing. And in class we'll talk about graphing by hand and with Desmos again. All right, so moving on to our first and actually only real kind of question for this lesson is, how is this different from systems of linear equations? Okay, it's basically the same idea. It's just that for inequalities, the solution is now going to be a region. A region instead of just a point. Okay, so it's going to be kind of an area on our plane. Okay, so let's start with this example. I have these two lines. Let's start with this one being red. Okay, so this first one, talk about it down here. It's a greater than. It's already in y equals mx plus b form, so I can just kind of get right into the problem. Okay, it's greater than, which means I'm going to use a dashed line because it doesn't include the equal sign, right? If it does, it would be solid. Because it's greater than, I'm going to then shade above the line. Okay, like our notes from 5-6. Okay, so let's graph this. I have a y-intercept of +1. I start here on my graph. Slope of -2, which means I'm going to go down 2 over 1. So that's my next point. And if I want to be more accurate, I can do that a few more times and then create my dashed line. Okay, so there's my first line. Remember we said I'm going to shade above it, so I'll just kind of shade this area lightly like that with red. Okay, for the second graph, I'll go ahead and do that in blue. For this one, it's a less than or equal to sign, which means that I'm going to have a solid line, and I'm going to be shading below the line because it's less than. Okay, I start at my y-intercept, which is +3, so up here. The slope, there's an invisible 1 here, so it has a slope of 1, or I could go up 1 over 1. Okay, and that's how I'd get my line. Again, it's solid. Okay, so there's my line. I'm shading below, so it's the y values that are below the line, so down here. And I can see they're overlapping in this area, okay, the right part of the graph. Maybe I want to shade that in another color like purple to kind of emphasize this is what they share. Okay, so what that basically means is that if I were to pick a point in this region, like let's say the point 3, 2 is this point right here. Okay, that's in the shared region, so if I plug in 3 for x and 2 for y, in both of the inequalities, I'm going to get something that's true. So like the first one would say 2 is greater than, -2 times 3 would give me -6, plus 1 is -5, so that's true. This one would say 2 is less than or equal to 3 plus 3 is 6, so that's true. Okay, so picking a point just kind of gives me, it makes both of the inequalities true. All right, moving on to our next example. Okay, graphing this system. Okay, this is just example 2. I'm going to start, let's see, red and blue again. Okay, for the first one, I'm going to have to mess with this equation a little bit, right? Because it's not in y equals mx plus b form yet. So I'm going to start by subtracting 3x. Sorry, I just wrote the wrong number. I'm going to subtract 3x from both sides. I get negative y is greater than or equal to negative 3x plus 2. I divide everything by negative 1. This sign flips around because I divided by a negative, so I get y is less than or equal to negative divided by a negative is a positive 3x, and positive 2 divided by negative 1 would be negative 2. Okay, to graph this, it's going to be a solid line because it's less than or equal to, and I'm going to shade below because it has less than. Okay, I start at the y-intercept, which is negative 2. I go up 3 because that's my slope, so I'm going up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Okay, and it's a solid line, so I connect. Okay. Oh, and shade below, so it's the y values below the equation. Okay. Looking at the blue line now. Again, I'm going to have to rewrite this. Okay, so I subtract 3x from both sides. I want that y by itself so that it's in kind of the normal form. Okay, I divide by negative 1. Dividing by negative means my sign is going to flip. This is just y is greater than 3x, and then minus 5. Oh, sorry. I wrote this wrong. This should have been minus 5, which makes this plus 5. Okay. The greater than sign means I'm going to have a dashed line, and I'm going to shade above the line. Okay, so I'll just kind of zoom out here. I start at the y-intercept, which is negative 5. I'm sorry, positive 5. Positive 5, I start here. My slope is 3, so I need to go up 3 over 1. I'm kind of out of space, though. So instead of going up and over, I can go backwards and go down and to the left. Okay, so I go down 1, 2, 3, to the left 1. 1, 2, 3, 1. Okay. If you think about it now, if I go from this point here to this point, it goes up 1, 2, 3 over 1. So that's kind of why the backwards thing works. Okay, this is a dashed line. So I'll go ahead and try to make that without being too messy. Straight edges definitely come in handy here. Okay, we're shading above, so I'm going to shade the y values that are bigger. So I go this way. And wait a second, they don't have anything in common, right? You'll notice these lines are parallel, so even if I could like zoom out on the graph, there's never going to be an area where those things intersect. The red is always below this line, and blue is always above. You can almost think about this like a road. Okay, this is like two sides of the street. They're not all of a sudden going to join. So, okay, maybe you could think what this means. Okay, if they don't overlap at all, then there's no numbers. There's no x and y that make both of these equations true, or both these inequalities true. So we say there is no solution. Parentheses, there's no overlap. Okay, so it's just kind of a different example, but hopefully you could tell visually how those are not going to overlap and why that would mean there's no solution. Okay, and final page here, last example. Okay, I know it's a little bit of a word problem, but it's not too bad. So it says the sign shows some restrictions for an auto racing school. Write a system of inequalities for the height and weight, then graph. Okay, so rules to qualify, you have to be 18 years of age or older. That's not really important because it doesn't have to do with height or weight. You have to be in good physical condition. Okay, cool. Not important right now. Under 6'7" tall. So that's going to be height, right? And under, I'm thinking means less than, right? Your height has to be less than that. Again, under 295 pounds, that's going to be weight. Okay, so there's weight, there's height. Let's make those equations. Okay, so their height, or h, has to be less than 6'7". Maybe instead of having that be 6'7", I could change it into just inches. For now, I guess I could leave it like this. And then weight needs to be less than 295 pounds. Okay, so I realized that graph is not going to work. We'll put in a new one. But let's convert this for the height. So less than 6'7". So 6 foot I would multiply by 12, right? That's going to give me 72. And then plus 7 would be 79 inches. So the height has to be less than 79 inches. The weight has to be less than 295 pounds. If I want to change these to like X and Y so that we can graph them on, let's say, Desmos, because that's what I'm going to show you next. It doesn't really matter, but let's just remember our numbers, 79 and 295. Okay, so I'm going to switch over to Desmos now. So I don't feel like making a graph that big. So I'm going to start with the weight. I'll use that as X. So X has to be less than 295. Okay, just kind of typing it in using the symbols on Desmos. And then Y has to be less than, so I already did the weight, so this must be the height. So Y has to be less than, we said it's 79 inches. Okay, so if I zoom out here, okay, you'll see it's just kind of like a shaded blur. But, oh, hey, now I'm getting something, right? Okay. So if we look at this graph, okay, the area where they're overlapping is in this box, right? Where it's kind of a rectangle, okay, where the height is less than 79 inches and the weight is less than 295. So that overlapping area would be the solution to our system.